And we can put plus 5y. And now notice that these are the same as well. These are what we call constant terms. So we would put plus -4 and plus -11. Minus 11 plus -11 mean the same thing. So now let's combine the things that are like terms. What do I get when I put together 3x and -4x? I get -1x. I'll bring down my 5y because nothing goes with that. And then -4 and -11 together give me -15. So you can write that in a few ways. We can write, when there's a coefficient of 1, -1, I don't write it, so I would just write -x plus 5y minus 15, or plus -15 work just fine. Okay, let's try example 2 together. Example 2 has to do with combining expressions vertically. So what we just did here, we expanded it using the additive inverse property, and then we saw what we put together and kind of did it side by side. I really like this method because this combining expressions vertically because it puts your like terms together for you. So vertically meaning up and down, so I would write 5a plus 3b minus 6c plus 2a minus 4b plus 13c. So notice your like terms are together. So I have 5a and 2a, which together give me 7a. I have 3b plus -4b. 3 plus -4 gives me -1b. And I have 6, that's a -6c and a 13c. -6 plus 13 gives me 7c. So I would simplify this by writing 7a minus b plus 7c. Find the difference here by aligning the expressions vertically again. So we're going to do the same thing. We're going to write them up and down, but notice that this is a subtraction problem. So we learned a little while ago that you need to change your subtraction by doing the additive inverse. So we would write 2x plus 3y minus 4. Rather than writing minus, I'm going to write plus, and I'm going to take the opposite of 5x plus 2. So what does that mean? I'm going to bring down the front of the expression because no changes have been made. The opposite of 5x would be -5x, and the opposite of 2 is -2. So now whenever you put them together, you would write 2x plus 3y minus 4, it's an addition problem, plus -5x, I would put it under the x, minus 2, I would put it under the constant term here. And now you can combine like we did a minute ago. 2 plus -5x gives me -3x. There's nothing to put with the 3y, so I just bring it down. And -4 plus -2 gives me -6. So my answer is -3x plus 3y minus 6. Turn the page. Using expressions to solve problems. So let's see a real life situation in where we would deal with these expressions and needing to simplify them. It says a stick is X meters long. A string is 4 times as long as the stick. Express the length of the string in terms of X. So we know that the stick is X, and we don't know how long the string is, but the string refers back to the stick, and it's 4 times as long. So if the stick is X and the string is 4 times that, I would write 4 times X for the string. You could write it with the dot if you wanted to, or with parentheses, but pretty much right now you're going to see it like this with nothing in between it. If the total length of the string and stick is 15 meters long, how long is the string? So we have two items here. We have the stick and we have the string, which together give us our total. I like to write it in words first and then fill in the numbers with the words. Fill in the numbers for the words. So we know the stick, it told us up here is X, so I'll write X. We know the string was 4 times X, so I write 4 times X. And based off of the problem, we know our total is 15. But you have learned in previous lessons that we can combine like terms. The coefficient here, when there is not one, remember is 1. So if we're going to combine these like terms, we get 5x equals 15. 5 times what gives me 15? Well, you could divide by 5 on both sides to see that x equals 3. So the string is 3 meters long. Okay, let's look at a little more complex of a word problem. It says expressions from word problems. It cost Margot a processing fee of $3 to rent a storage unit plus $17 per month to keep her belongings in the unit. Her friend Carissa wants to store a box of her belongings in Margot's storage unit and tells her that she will pay her $1 towards the processing fee and $3 for every month that she keeps the box in storage. We need an expression in standard form that represents how much Margot will have to pay for the storage unit if Carissa contributes. Then determine how much Margot will pay if she uses the storage unit for 6 months. So we're going to let M represent the number of months. M equals months. There we go. We know that we have what Margot needs to pay and what Carissa needs to pay. Now we have Margot and Carissa, but if our expression is going to represent how much Margot will have to pay for the storage unit if Carissa contributes, then we're not really going to add both of them together. We're going to take Carissa's amount that she's paying away from Margot, because that's less that Margot has to pay. So from the problem up here, Margot has a processing fee of $3 and $17 per month. We don't know how many months, so 17 times M plus that $3 fee minus what Carissa does. Carissa said she's going to pay $1 towards the fee and $3 per month. Here's $3 per month and the $1. So if we simplify this, this will tell us how much Margot will have to pay. Notice it said in standard form over here, so that means that we need it to have to be simplified and nothing left to be combined. Right now we can do some combining because this is subtraction, so we're really going to add the opposite. Now what is the opposite of 3M? Negative 3M. What is the opposite of plus 1? Minus 1. So now, if we rearrange them and put our like terms together, it might help you see. Put our constants together, the 3 and the negative 1. If I put 17M and negative 3M together, I'm going to end up with 14M because they're different signs subtract. Take the sign of the larger number, then you'll be exact. I'm going to put my 3 and negative 1 together to get 2. So here is if I go back to what the problem asked, an expression in standard form that represents how much Margot will have to pay for the storage unit if Carissa contributes. So here is our expression in standard form. Then determine how much Margot will pay if she uses the storage unit for 6 months. Well, remember M stood for months, so I'm going to do 14M plus 2. I'm going to fill in a 6 for M and use order of operations. Order of operations is do multiplication first. 14 times 6 gives us 84, and 84 plus 2 is 86. What does 86 mean? 86 is money, dollars. Margot will pay $86 towards the storage unit. For 6 months. Okay, and let's see. Last one, we have example 5. Extending use of the inverse to division. So we know that adding the opposite allows us to combine like terms. So let's see, it says multiplicative inverses have a product of 1. So when you multiply opposites, they give you 1. Find the multiplicative inverse of the terms in the first column. Show that the given number and its multiplicative inverse have a product of 1. Then use the inverse to write each corresponding expression in standard form. The first row is completed for you. So they took 3, which you would multiply by 3 to get 1, is its reciprocal. So flip it over, we get 1 over 3. Here's proof that it gives me 1 because I multiply straight across. And then that allows me to see that dividing by 3 is the same thing as multiplying by 1/3. And if you put your whole number over 1, multiply straight across, it would simplify to 4. So what's the multiplicative inverse of 5? 1/5. Meaning if I multiply 5 times 1/5, I put my 5 over 1, I multiply straight across, get 5 over 5, which equals 1. The fact that I know that allows me to do 65 divided by 5. That's the same as 65 times 1 over 5. Whole numbers go over 1. I get 65 divided by 5, which is 13. Is that right? Yes. Let's do -2. What is the multiplicative inverse of -2? Now remember, it's not the additive inverse, it's the multiplicative inverse. So what do I multiply by -2 to get 1? My sign stays the same, but what's the reciprocal of 2? 1 over 2. So that means that -2 times -1 over 2, whole numbers go over 1, multiply straight across, so I get 2 over 2. A negative times a negative, it's just like your shoes. If they match, it's positive. If they don't, it's negative. A negative times a negative is a positive, and 2 divided by 2 is 1. By understanding that, that allows me to know that 18 divided by -2 is the same thing as 18 times -1 over 2. So dividing by 2 is the same thing as multiplying by 1/2. Whole numbers go over 1. We can multiply straight across. A positive times a negative is a negative. 18 divided by 2 is 9. -9. What is the multiplicative inverse of -3/5? Again, sign stays the same. Find the reciprocal. 3/5 is 5/3. So -3/5 times -5/3. Negative times a negative is a positive, and 3 times 5 and 5 times 3 both give us 15. Again, we get 1. So 6 divided by -3 over 5. Remember, to divide, it's the same thing as multiplying by the multiplicative inverse. So my sign stays the same, but I find the reciprocal. Whole numbers go over 1, and positive times a negative is a negative. 6 times 5 is 30, and 1 times 3 is 3. So that simplifies to give us -10. Whoops. Let's take that to expressions now. What is the multiplicative inverse of x? Well, remember it goes, you could put it over 1, so the multiplicative inverse would be 1 over x. That means x times 1 over x. Whole numbers go over 1. Anything times 1 is itself, so we get x over x. Anything divided by itself, again, gives us 1. So if I take this expression here, 5x divided by x, that's the same thing as 5x times 1 over x. We just proved that a minute ago. So I put whole numbers over 1, multiply straight across, and 5x divided by x over x, remember that's 1, would give us, those two kind of cancel, and we get 5. And last one, 2x. The multiplicative inverse of 2x is 1 over 2x, because you just flip it over. We could have done this to those if you needed to. So 2x times 1 over 2x, whole numbers go over 1. We get 2x over 2x. That top and the bottom basically cancel, cancel. So we end up with 1. 2 divided by 2 is 1. X divided by x is 1. 1 times 1 is 1. So 12x divided by 2x is the same thing as 12x times 1 over 2x. Whole numbers go over 1. Multiply straight across. And 12 divided by 2 is 6. X divided by x is 1. 6 times 1 is 6. So we took our knowledge of the multiplicative inverse and applied it to expressions. We started with just whole numbers, and we went down here to expressions. Okay, on this next page it has some very important vocabulary that you need to understand. Remember the difference in expanded form and standard form. Standard form isn't going to have anything left to be combined. Expressions in expanded form do have parts that can be combined. A term is the words of the mathematical sentence, and the coefficient of the term is the number in front for the multiplying. So in this example, 8. So why can't we use any order, any grouping directly with subtraction, directly with division? Why was it important that we saw additive inverse and multiplicative inverse? Well, because subtraction and division do not have the commutative or associative property. We had to change them to that addition and multiplication to see that. And how can we use any order, any grouping in expressions where subtraction or division is involved? Well, we write subtraction as adding the opposite, the additive inverse, and we write division as multiplying by the reciprocal, which is the multiplicative inverse. Okay, get started on your problem set. Use your notes to guide you. Go back to your lesson summary. These are all the main important points that we just discussed. You have front and back of this page. Good luck.